question 11 says, consider the series 1 over 1 squared minus 1 over 1 plus 1 over 2 squared minus 1 over 2 plus 1 over 3 squared minus 1 over 3, so on and so forth. Okay, so we have an alternating series here. And part A asks, does this series satisfy the conditions of the alternating series test? Okay, so as I noted, right, we have an alternating series. And for our sequence B sub n, we have B1 is equal to 1. B2 is equal to 1 as well. And remember, the B sub n's are all non-negative, so you can think about just ignoring the signs in front of each term. B3 is a quarter, B4 is a half, B5 is a ninth, B6 is a third, so on and so forth. Okay, so the first condition for the alternating series test says that the sequence B sub n needs to be decreasing, and that's clearly not the case here, right? We have 1, 1, and then we decrease, increase, decrease, increase, and then we'll have another decrease, increase. And in fact, this decrease to increase behavior is going to continue indefinitely, no matter how far out we go in the sequence. Okay, we're comparing 1 over a number squared to just 1 over that number. Okay, so we're always going to get that decrease to increase behavior. So it is not true that the sequence is decreasing for all n. Now, in some of the problems we've seen with alternating series, we said, okay, hey, the first few terms do not exhibit decreasing behavior, but as long as the sequence eventually starts to decrease, then we're okay. Well, because of this, again, behavior of decrease then increase continuing indefinitely, okay, this sequence is not even eventually decreasing. Okay, so the conditions for the alternating series test do not hold, and so the answer there for part A is no. Now part B says, does this series converge or diverge? Why is this? All right, well, first note that if I group the terms where I have the squares in blue, so 1 over 1 squared plus 1 over 2 squared and so on, and then I group these terms without the squares in red, so 1 over 1 plus 1 over 2 plus 1 over 3 and so on, this blue series is a p series with p equal to 2, and so it converges. This is just a harmonic series, or in other words, it's a p series with p equal to 1. And so this blue series converges to some number. It actually happens to converge to the number pi squared over 6, as I mentioned a while ago, but the point is that it's convergent, so it's some finite value. But then we're subtracting the harmonic series, which we know is infinite. And so we conclude that this series then, that we're given in this question, is divergent. Okay, so that does it for this question, but before we finish, I do want to end with one disclaimer. Okay, now in part A, it says, does the series satisfy the conditions of the alternating series test? And we said no. Okay, you have to be a little careful there. Is that enough to conclude then that the series diverges? Well, the answer there is no. Okay, what the alternating series test says is that if this sequence B sub n is non-negative, it's decreasing and approaches 0, then this alternating series does converge. Okay, so if these conditions on B sub n hold, then the alternating series converges. That's what the alternating series test says. What it does not say is that, hey, if one or more of these conditions on the B sub n fails, then blah, 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 blah about this alternating series. It doesn't tell you anything if one or more of these conditions on B sub n does not hold. And that's what I'm saying here. I say, if B sub n does not satisfy all of the above conditions, we can't conclude from this alone that this alternating series diverges. It may diverge or it may converge. Now, in this particular case, this series did happen to diverge, but I could easily cook up an example where not all of these conditions on B sub n are satisfied, and yet the alternating series converged. Okay, so that's why I say here, you have to try something else. All right, great. Well, that's going to do it for this problem. Thanks.